Welcome to the deep dive, where we cut through the noise and get straight to the insights you need. Imagine for a moment, if a critical medical breakthrough depended entirely on a patient's historical scans from decades ago.
Right. Or maybe a multi-million-dollar lawsuit hinging on just one single email sent 15 years back.
Exactly. In our, hyper-digital world, data isn't just created, it's destined to live on, often for far longer than we anticipate. We're talking everything from every photo on your phone to mission-critical business reports, complex medical images used in hospitals. It's just an absolute avalanche of information.
It really is. And in this on-command, on-demand 21st century, we don't just need that information now. We need it years, even decades down the line. And it has to be reliably accessible and, crucially, entirely authentic.
Yeah, authenticity is key.
It's true. The sheer volume is, well, it's mind-boggling. And the expectation for constant accessibility, relentless. What's truly fascinating, though, is that the amount of information generated by individuals each day, through their cell phones, social media, smart devices, it far exceeds what organizations typically produce.
And really, individuals create more.
Oh, absolutely. Every digital interaction, every piece of content created leaves behind this trail, right? A digital footprint that eventually needs a permanent, manageable home.
And that reality brings us straight to today's deep dive. An often underestimated yet absolutely crucial aspect of modern information management data archiving. Now, this isn't just about, moving old files to some dusty corner of your hard drive and forgetting about them. Far from it.
Not at all. This is about intelligently preserving our digital history. It's about ensuring its long-term accessibility, maintaining its integrity, and perhaps most importantly, unlocking its continued usefulness and value over time.
Okay, so our mission today is to take a deep dive into this core concept of fixed content. We need to understand precisely what it is and why it's growing at such an astonishing rate.
Right. And then we'll expose the, well, surprising limitations and hidden costs of those traditional storage solutions that used to be the standard. Tapes and disks.
Yeah, I remember those.
And finally, we'll reveal the innovative architectures and, frankly, game-changing technologies that are fundamentally transforming how organizations manage their digital legacies today.
So by the end of this deep dive, you'll gain a quick yet thorough understanding of how fixed content is handled, from the basic definitions right through to the practical solutions driving modern data management. Okay, let's unpack this. Foundational question first. We're talking about fixed content. It sounds pretty straightforward, maybe. But it has a very specific meaning in this complex world of data storage. It's different from just old data, isn't it? What exactly do we mean by fixed content when we discuss data archiving?
That's a really crucial distinction to make right at the start. Fixed content is essentially data that, well, in its life cycle, it begins as actively created, accessed, frequently changed information. Think about like a legal brief your team is drafting, or maybe a financial spreadsheet that's updated hourly. It's dynamic, right? It's alive.
Constantly changing.
Exactly. But as it ages, as it matures, its nature fundamentally shifts. It becomes fixed. And what we mean by fixed is that it's highly unlikely to be modified or updated again. Think about it. Once a contract is signed or a patient's X-ray is taken, the content itself isn't expected to change.
Right, it's done, locked.
Precisely. But despite this immutability, this fixed nature, it remains incredibly valuable. And it continues to be accessed by applications and users for all sorts of reasons: compliance, historical analysis, maybe even informing future decisions. So it's not simply static or forgotten data sitting there. It's information that is transitioned into a stable, immutable record. Yet it still retains an active role for retrieval and analysis, often for very long periods.
That makes a lot of sense. So it's data that's kind of matured into a permanent record. Okay. Can you give us some concrete examples? Like, what kind of digital treasures truly fall into this fixed category in the real world? Things you might encounter.
Oh, absolutely. Our source material highlights a really wide range of examples that illustrate this perfectly across different industries. Consider, for instance, medical images. Things like X-rays, MRIs, CT scans. Once that scan is performed and a diagnosis is made, the image itself doesn't change, right?
No, you wouldn't want it to.
Exactly. Yet, it absolutely must be accessible for future consultations, for comparisons, follow-up treatments, or just strict regulatory compliance, sometimes for decades.
Well,
I mean, imagine the liability if a doctor couldn't access a patient's historical scans. It's unthinkable.
Yeah, that's critical.
Another really compelling example comes from engineering. Think about complex design files, like CAD/CAM models for aircraft, cars, even your smartphone. These designs, once they're finalized and the products are manufactured, they become fixed content. But they are absolutely vital for future product iterations, maintenance, repairs, or even just documenting intellectual property.
Okay, so design files too.
Then there's surveillance video footage.
Mm.
Once it's recorded, the raw footage itself can't be altered, but it must be retained for security investigations, legal evidence, compliance purposes, often for months or years, depending on the regulations.
Right.
And even something that seems more mundane, like personal media, your MP3 collection, or your digital family photos. Once you've taken that photo or ripped that song, its content rarely changes, but you might access it countless times over the years, right?
Definitely. My photo library is huge.
And of course, critical financial documents, ledgers, transaction records, contracts, invoices, tax filings. These are perhaps the quintessential examples. They are immutable records. They must be preserved with absolute integrity for audits, compliance, historical financial analysis, often for very extended periods, decades sometimes.
So the common thread.
The common thread across all these examples is that once they're created, their content doesn't typically change. But the ongoing long-term need for access and the absolute assurance of their original, authentic state that persists.
Okay, now here's where it gets really interesting, or maybe even a bit scary. This fixed content isn't just sitting still, it's exploding. Our source notes it's growing at over 90% annually. That's the staggering figure, especially for data that, as you just explained, isn't actively changing. What on earth is driving such exponential growth, particularly for information that's effectively becoming immutable once it's created?
It truly is astonishing, isn't it? And it represents a massive shift in how we have to think about data volumes, the primary driver. It's the sheer proliferation of content-generating devices in virtually everyone's hands. Your cell phone, your tablet, digital cameras, smartwatches, even smart home devices.
Everything's creating data now.
Everything.
Yeah.
And these technologies, combined with that on-command, on-demand nature of the 21st century we mentioned, it means that individuals are now creating and consuming far more digital information than traditional organizations, businesses, governments, nonprofits combined.
Wow.
Yeah. This massive digital exhaust. All those photos and videos from your last vacation, endless social media updates, detailed transaction logs, censored data from smart devices, archived chats, text messages. Once it's created, it needs to reside somewhere, right? And while much of it starts as active data, a significant portion eventually becomes fixed content that requires long-term preservation.
Like shared photos, you mean?
Exactly. Think about the billions of shared photos and videos uploaded to cloud services, or the countless archived email messages that, once sent, become permanent records. That information gains value when it's shared, and once it's uploaded to a central data repository, it contributes significantly to this exploding volume of fixed content that needs persistent, accessible storage. This rapid, decentralized creation of data is a major challenge for any organization trying to manage its digital footprint.
So it's not just what fixed content is, but the sheer relentless tsunami of it. Okay, and that brings us to the crucial question. With all this fixed content piling up at such an alarming rate, why the emphasis on archiving it in a dedicated way? Why not just store it like any other data? What's the specific driving force behind organizations creating and maintaining dedicated data archives?
That's a critical point, because dedicated archiving isn't just a nice to have. Often it's an absolute necessity, and it's driven by both external pressures and internal strategic goals. Firstly, and perhaps most prominently, you've got government regulations and stringent legal and contractual obligations.
Ah, the compliance angle.
Exactly. We're in an era where new laws are constantly being established and enforced. They dictate not only how long certain types of data must be kept, sometimes for decades, but crucially, they enforce the protection of these archives from unauthorized destruction and modification.
So it's about keeping it safe and keeping it unchanged.
Precisely. This isn't just about preventing data loss, although that's part of it. It's about ensuring absolute data integrity, provable content authenticity, and guaranteed availability. You need it for legal discovery during lawsuits, for internal and external audits, and just for general transparency requirements.
And the penalties for getting it wrong.
They can be truly significant. We're talking fines that can run into the tens of millions for data breaches due to poor retention practices, or crippling legal sanctions for failing to produce complete and authentic records during a lawsuit. Not to mention the irreparable damage to reputation and stock price. So, robust archiving isn't just a cost center. It's really a necessary insurance policy against potentially crippling liabilities.
Okay, so it's about avoiding catastrophic risks. big ones. But as you noted, it's not just about compliance and avoiding penalties. There's a powerful positive side to this, isn't there? A way to turn these vast archives into a real strategic advantage.
Exactly. Beyond compliance and risk mitigation, archiving also enables organizations to strategically leverage this fixed content. They can use it to generate new revenue strategies and significantly improve service levels. Think about the incredible insights you could glean from decades of meticulously archived customer transaction data, or historical scientific research accumulated over generations.
Stuff you can't get from just looking at today's data.
Precisely. This old data, when properly archived and made accessible, can fuel long-term trend analysis that no real-time analytics could ever capture. It can inform new product development, identify new market opportunities, or even be monetized as valuable historical data sets for academic research or industry analysis.
Can you give an example of that? Monetizing old data.
Sure. Imagine a retail company using 20 years of archived sales data. Might spot subtle long-term purchasing trends that lead to developing an entirely new, highly profitable product line, or maybe a hyper-targeted marketing strategy worth millions. Or think about archived historical weather patterns fixed, immutable data. They're now being sold to insurance companies to refine their risk models. That turns what was once static, dusty data into a dynamic revenue stream.
Wow.
It's about transforming what might appear to be static, historical information into a dynamic, strategic asset that informs future business decisions and creates entirely new value streams.
Okay, so strong drivers. Compliance, risk mitigation, strategic business value. Makes sense. So how do we actually do archiving in practice? The source talks about a data archive as a repository, but it's clearly not a one-size-fits-all solution. You mentioned different types, each with trade-offs, costs, accessibility, retrieval time. How does that spectrum work?
That's a crucial point, yes. And it's why organizations implement archiving solutions across a spectrum of accessibility. This allows them to tailor the solution to the specific needs of the data and their requirements for retrieval speed.
Okay, so what are the main types?
Well, at one end, we have the online archive. This is where the storage device is directly connected to a host server, making the data immediately accessible, typically within milliseconds.
If you're fast.
Right. It offers the fastest retrieval times. So it's ideal for fixed content that, while immutable, is still frequently accessed and needs to feel live to users. Think of active patient medical records that doctors consult daily, or maybe customer service logs agents need to pull up instantly.
Makes sense. What's the downside?
The trade-off here is generally a higher cost per gigabyte compared to other archive types. It often uses high-performance storage, sometimes even flash-based, for that instant access, so it's pricier.
Okay. What's next on the spectrum?
Moving along, we encounter the nearline archive. In this scenario, the storage device is also connected to a host, but the data needs to be mounted or loaded before it can be accessed. So there's a slight delay, but usually a predictable one, maybe a few seconds or minutes, while the system prepares the data for access.
So not instant, but close. Almost online.
Exactly. You can think of it as almost online. This offers a very effective balance between cost and accessibility. It's suitable for data that's accessed regularly, but perhaps not constantly, or where a small delay in retrieval time is perfectly acceptable. It's a good middle ground solution for many common archiving needs, like departmental shared drives where older project files are still occasionally needed.
Got it. And the last tape.
Finally, at the other end of the spectrum is the offline archive. This is the most cost-effective solution for very long-term retention of data that is rarely, if ever, needed quickly. Here, the storage device is not immediately ready for use. Significant manual intervention is required to physically connect, mount, or load it before the data can be accessed.
So someone has to physically do something, like find a tape.
Precisely. This might involve retrieving physical media like tapes or optical discs from a secure vault or an offsite location. That can take hours, maybe even days. The latency is highest here, and so is the manual overhead. But it offers significant cost savings for compliance or historical reasons where immediate access isn't a priority. Think very old tax records or geological survey data.
Okay, so online, nearline, offline, a range of options.
Right. And sophisticated organizations often use a combination, what's sometimes called a tiered archiving strategy, to manage their diverse fixed content efficiently, matching the access needs and value of the data to the cost of the storage tier.
It's clear that modern archiving demands that kind of sophistication. For a long time, though, if you mentioned archiving, people immediately thought of physical tapes or optical discs, right? CDs, DVDs. They were, for decades, the undisputed standard, what made them so prevalent initially. And why are they now largely considered inadequate for modern needs, especially with that crazy 90% annual growth rate we discussed? It seems like a massive mismatch.
You're absolutely right. They were the workhorses of data retention for a very long time. And there were reasons for that. Traditionally, tapes offered an extremely low cost per gigabyte for storing large volumes of data. That was especially appealing for long-term offsite preservation and disaster recovery. Their primary advantage was purely economic, especially for cold storage.
Cheap storage, basically.
Pretty much.
Sure.
And optical media, like CD-ROMs, provided another key advantage, that write once, read many, or worm capability. This was incredibly valuable for ensuring content couldn't be accidentally or intentionally overwritten after it was written. It offered a fundamental degree of data integrity for records that needed to be immutable for legal or compliance reasons.
Okay, so low cost and write once. Sounds good on paper.
For their time, these strengths made them seem like ideal, cost-effective solutions.
Yes. But our source material really highlights their profound shortcomings. Let's unpack those. Because it sounds like while they might have appeared inexpensive on the surface, they actually carried significant hidden costs and operational burdens. Burdens that made them entirely inadequate for the scale and demands of modern fixed content. What were the inherent problems that led to their downfall as primary archiving solutions?
You've hit on the core issue there. That apparent low cost often masked a truly significant total cost of ownership and, frankly, staggering operational complexity, especially as data volumes just exploded. There were several major challenges that severely limited their utility as fixed content began its exponential growth.
Okay, like what?
Firstly, the operational, management, and maintenance overhead was just immense. Think of the sheer labor involved with tapes. They require careful physical handling, precise labeling for identification, manual mounting into drives every single time data needs to be accessed.
Someone has to physically load the tape?
Every time. Furthermore, they demand stringent environmental controls, specific temperature and humidity levels for proper storage to prevent degradation and data loss. This meant dedicated IT staff just to manage these physical media libraries. It required specialized, climate-controlled facilities and complex logistical management for retrieving and tracking tapes.
Sounds like running a library, not managing data.
It really was. Less about managing data, more about managing an industrial-scale physical library operation, prone to human error, physical loss, environmental disaster, all adding considerable cost and complexity.
Okay, huge overhead. What else?
Secondly, a major inefficiency was the complete lack of content recognition and rampant duplicate storage. These traditional solutions weren't designed to intelligently recognize content at all. So if the exact same data existed in multiple places, maybe copied by different users, or if it was part of repeated daily or weekly backup cycles, it was stored multiple times. No intelligent deduplication.
So the same file stored over and over again.
Over and over and over. This led to massive unnecessary consumption of storage space. It duplicated not just the data itself, but also the effort and resources required to store and manage it. It was a monumental waste of costly storage media.
Wow, that seems incredibly inefficient.
It was. Thirdly, there were significant additional costs for offsite storage and media management. For robust disaster recovery or very long-term preservation, these physical media often needed to be transported to secure offsite locations, like an Iron Mountain facility. This introduced further costs for transportation, often requiring specialized secure couriers to mitigate the risk of loss or theft. There was also the ongoing expense of managing those offsite facilities.
And getting the data back must have been a pain.
A logistical nightmare. Tracking and retrieving specific physical tapes or disks when needed was complex. And crucially, it significantly increased the inherent risk of loss or theft of sensitive data during transit, sending tapes across town. Not ideal.
Security risks.
Fourthly, they were highly susceptible to wear and tear and environmental degradation. Physical media simply degrade over time, and with repeated use. It's physics. Tape drives, for instance, have read-write heads that physically touch the tape surface. That inevitably leads to wear and tear on the tape itself.
Like an old cassette tape.
Exactly. This can manifest as read-write errors or, in severe cases, head crashes that result in permanent data loss if the head damages the magnetic coating. Optical discs also have limited shelf lives, and environmental factors like temperature fluctuations, humidity, even light exposure can significantly accelerate their degradation, making them unreliable for true long-term archiving.
So they just don't last forever reliably.
Not without careful management and migration. Which brings us to the fifth point. frequent technology changes, and conversion overhead. This was a truly critical issue for long-term accessibility. The rapid evolution of storage technologies meant that older tape formats or optical disk types would quickly become obsolete. New drives couldn't read old media.
Like trying to play a floppy disk today.
Precisely. Accessing data from decades past might require maintaining outdated, specialized hardware. Imagine today needing a working 8-track player or an ancient floppy disk drive just to access a document from the 1990s. It's impractical. Highly. Organizations would then be forced to undertake costly and time-consuming media migration processes, converting data from old, unsupported formats to new ones just to ensure continued accessibility. This constant need for migration was a significant risk for long-term archives. A failure to migrate meant inaccessible data, a silent data graveyard.
Okay, and one more issue.
Finally, these solutions often fail to meet evolving regulatory requirements. As new government regulations and industry standards emerged, particularly those stipulating stricter requirements for preserving information integrity, protecting against unauthorized destruction or modification, providing detailed audit trails. Traditional solutions, with their inherent vulnerabilities, just struggled to consistently meet these evolving demands for content authenticity and robust retention enforcement. They simply weren't built with a modern regulatory landscape in mind.
So, we've painted a rather bleak picture of the past there. It sounds like a problem so profound, so costly in its hidden burdens, that it demanded a complete rethinking of how we store long-term data. And that, I gather, is where the true breakthrough of content address storage, or CAS, enters the scene. That fundamentally changed the game.
That's a perfect lead-in, yes. These accumulating limitations drove an urgent need for a more intelligent, robust, and scalable solution specifically for fixed content. And you're right, that's exactly where content address storage, or CAS, truly came onto the scene as a game-changing alternative. It's a disk-based storage system designed from the ground up to address the very specific and unique demands of fixed content archiving, moving away from those physical limitations of tapes and disks.
Okay, so what makes CAS fundamentally different from what came before? Why is it considered such a significant advancement in archiving? How does it actually work differently?
The fundamental difference in CAS lies in how it identifies and stores data. It's quite ingenious, actually. Unlike traditional block or file-based storage systems that rely on physical disk locations or hierarchical file paths, C folder file .doc.
Yeah, the way we normally think of files.
Right. CAS uses a unique content-derived address for each object. Think of it like this. You feed any digital file, a photo, a document, an entire movie, into a kind of digital fingerprinting machine. This machine is essentially a specialized algorithm, usually a cryptographic hash function like SHA-256. It instantly generates a unique fixed-length code like a digital DNA sequence based purely on the object's binary representation.
A fingerprint based on the actual data itself.
Exactly. This content address is as unique as a fingerprint for that specific piece of data. And here's the magic. If even a single bit of the content changes, if you change just one tiny pixel in that photo or a single comma in that document, that digital DNA completely transforms, creates a new distinct address.
Ah, so it guarantees authenticity.
It's an unbreakable cryptographic guarantee of data authenticity and integrity. If the fingerprint matches the original one stored, the data hasn't been touched since it was stored, period.
That's powerful. What else?
Though this content-derived addressing provides several profound benefits. Firstly, it inherently handles what's called single-instance storage, or SIS. What that means is, if the exact same data object, say, a common company policy PDF, or a widely distributed internal memo, is written to the CAS system multiple times by different employees or applications.
Which happens all the time.
All the time. It's not stored redundantly.
Yeah.
The system sees the exact same digital fingerprint for all those identical copies, and it only stores one master copy. It then just links all the others back to that single instance.
Like having one master key for 1,000 identical locks.
Perfect analogy. This dramatically reduces storage consumption, eliminates duplicate effort, and optimizes resource utilization. I mean, before CAS, organizations were drowning in redundant data. We saw cases where they were storing 5, 10, even 20 identical copies of the same document across different systems. A monumental waste of costly storage.
So CAS could slash storage needs.
Oh, easily. SIS wasn't just an efficiency gain. It represented a paradigm shift that could slash storage needs for fixed content by 30–50%, sometimes even more, almost overnight. That freed up budget for innovation, not just managing data sprawl.
Incredible savings.
Absolutely. And beyond that, CAS was explicitly designed from the ground up to meet the stringent requirements of archives data. This includes significantly improving data accessibility by providing online, disk-based storage for fixed content, protecting that data integrity through its unique addressing and continuous validation checks, managing retention and disposition policies automatically without manual intervention, and ensuring that archive data can meet demanding service-level agreements, SLAs, for retrieval. It offers much better scalability and manageability compared to its predecessors. It ultimately moves archiving from that manual, reactive, library-like process to an intelligent, automated, and policy-driven one. It truly is a foundational shift.
Okay, that's a fascinating look at the underlying technology of CIS. Really clever stuff. But if CIS is the engine, what does a modern data archive solution actually look like in practice? Our source identifies 3 key components that work together to make this intelligent archiving happen. Let's break down this architecture piece by piece, like dismantling a complex machine to understand its working parts.
That's a great analogy. And yes, think of it as a highly specialized, intelligent workflow designed specifically for fixed content. The 3 crucial pieces are indeed the archiving agent, the archiving server, and the archived storage device. And they don't operate in isolation at all. Rather, they form this intelligent ecosystem that automates and orchestrates the entire archiving process, from the initial data identification right through to long-term preservation and transparent retrieval. Each component plays a vital, interconnected role.
Okay, let's start with the archiving agent. What is its specific role in this sophisticated system? It sounds like the frontline worker in this operation.
That's a perfect way to describe it. The archiving agent is a piece of software, and it's installed directly on the application server, the very source of the data that might need to be archived, like the file server or the email server itself. It acts like a vigilant, automated librarian, constantly scanning the data residing on that primary application server.
Scanning for what?
Its scanning is based on specific, predefined policies that have been meticulously configured by administrators, usually on the central archiving server. So once the agent identifies data that meets these archiving criteria, maybe it's a document that hasn't been accessed in 6 months, or an email older than 90 days, it's responsible for efficiently sending that data over to the archiving server.
Okay, it finds the old stuff and sends it off.
Right. But here's where a fascinating and crucial detail comes in. A bit of digital magic, you could say. The agent doesn't just copy the data and leave the original in place. After the data is successfully and securely transferred to the archive, the agent replaces the original, often much larger data file, on the primary storage with a tiny placeholder. And this placeholder is called a stub file.
A stub file. Okay, that's incredibly clever. What's the practical benefit of having this tiny file? And does it mean the original full-size data is actually gone from the primary storage? It sounds a bit like an illusion.
It is, in a way, a very effective illusion for the end user, but entirely real in terms of data management. Yes, the original full data file is indeed moved off the primary, often more expensive, high-performance storage, and safely into the dedicated archive. The stub file is absolutely crucial. It maintains a seamless user experience while achieving significant storage optimization. It's incredibly small, typically just a few kilobytes.
Tiny compared to the original file.
Exactly, which drastically saves space on that primary storage. Space that can then be used for active, frequently changing data, or it simply reduces the overall cost of that high-tier storage.
Okay, save space. But how does the user get the file back?
Right. More importantly, this stub file isn't just a simple placeholder. It contains the unique address or pointer to where the actual archive data now resides in the archive streams device. The system manages a kind of digital directory, mapping these tiny stubs back to their much larger counterparts in the archive.
So the stub knows where the real file went.
Precisely. So, if a user or an application tries to access what they perceive as the original file, maybe by clicking on it in a shared drive or trying to open an old email from their inbox, they seamlessly interact with this stub file. The underlying system then automatically uses the information in the stub to retrieve the actual data from the archive storage device, and it makes the entire process transparent to the user.
So they don't even know it's happening.
From their perspective, it's as if the file never left its original location. It's like having a miniature instant map on your desktop that takes you straight to a remote, vast library to fetch the exact book you need without you ever having to know where that library actually is or how it's organized.
That's a truly elegant solution, maintaining user experience while optimizing storage. Very clever. Okay, so the agent handles the initial identification and that clever stub trick. Next in our architectural lineup is the archiving server. What's its function? It sounds like the central command.
It really is. The archiving server is truly the brain, or the central control point of the entire archiving solution. It's typically software installed on a dedicated host within the data center. It acts as a mission control for all your fixed content. This is the critical location where administrators define and meticulously manage all the archiving policies.
The rules the agent follows.
Exactly. These policies are the precise rules that the archiving agent follows when it scans and identifies data on the application servers. And these policies can be highly granular and sophisticated, designed to meet very specific business or regulatory requirements. For instance, they can be based on criteria like file size, archive all files larger than 100 MB to Tier 2 storage, or by file type, archive all MPG video files after 6 months of inactivity.
Or by age, like the email example.
Right. A very common and powerful policy criteria is based on specific timestamps, creation date, modification date, or, crucially, the last access time. For example, a policy might state, automatically archive all emails older than 90 days that haven't been accessed in the last 30 days.
So it manages the what and when.
Exactly. The archiving server orchestrates the entire process. It receives the identified data from the archiving agents, it applies the necessary metadata and retention tags based on policy, and then it intelligently directs that data to the appropriate archive storage device. It ensures the right data goes to the right place according to the set policies, and it manages the overall flow and integrity of the archive. It also handles the retrieval requests initiated by those stub files, coordinating getting the data back.
Okay, the brains of the operation. And finally, we arrive at the ultimate destination, the archive storage device itself. This is where all that fixed content truly rests. What's its specific long-term role within this architecture?
The archive storage device is, well, it's the ultimate destination. It's the secure vault where the fixed content resides for its long-term retention. And as we discussed earlier, this is very often a content address storage CAS system, precisely because of its inherent benefits for managing fixed content, guaranteed content authenticity, highly efficient single-instance storage, robust retention enforcement.
So it's built for this job.
It really is. It's not just a place to dump data. It's engineered specifically for longevity and integrity. Its core role is to reliably store and protect the data, ensuring that it remains authentic, unaltered, and accessible for years, often even decades, to meet those stringent regulatory requirements and critical business needs we talked about.
Durability is key here.
Absolutely. It's designed with durability in mind, often employing multiple copies across different locations or advanced error correction techniques to ensure data survival even in the face of hardware failures or other issues. It's the persistent layer of the archive, designed for extreme durability and the efficient retrieval of immutable objects. It ensures that when that stub file is clicked years from now, the data is there in its original pristine state, ready for use. It truly represents the final, secure resting place for your organization's digital legacy. It's like the digital bedrock of information.
Okay, let's bring all of this sophisticated architecture and technology down to earth. Let's talk practical, real-world examples. One area where archiving solutions have had a truly massive, almost liberating impact is email. I mean, who hasn't wrestled with an overflowing inbox? Constantly deleting messages to free up space? It's a universal pain point, that constant battle against the mailbox full notification.
Oh, absolutely. You've hit on a problem familiar to virtually everyone who uses email for work. Email archiving is a prime example of how these solutions provide tangible, immediate, and long-term benefits. It addresses a challenge that nearly every organization, regardless of size, faces. Because traditionally, IT system administrators were forced to configure relatively small mailboxes, or they set strict quotas on mailbox sizes.
Why did they do that? This seems counterproductive.
Well, they did it for very practical reasons. Managing massive mailboxes with an ever-growing number of emails was incredibly difficult. It significantly increased primary storage costs, as email servers often sit on expensive, high-performance storage, and large volumes of data could severely degrade the overall performance of the email system itself, leading to slow searches, sluggish client applications. It was an operational headache.
Okay, so IT needed to keep things manageable.
Right. But this administrative reality forced users into that constant, frustrating struggle. They had to delete emails regularly as they approached their quota limits. This wasn't just a major source of frustration for end users interrupting their workflow, it was also incredibly risky from a business perspective.
How so?
Well, users frequently need to access emails that are weeks, months, or even years old. For compliance reasons, for historical context on a project, for tracking customer interactions, for ongoing legal matters, losing that information or spending hours trying to track it down because it was deleted or manually archived somewhere random created both a productivity drain and significant legal liability. It was this constant trade-off between operational efficiency for IT and user productivity, and often both suffered.
Yeah, I've definitely felt that pain. So, what does a modern email archiving solution actually do to solve these persistent problems? How does it finally liberate our inboxes from those dreaded quotas? How does it transform that experience?
An email archiving solution fundamentally transforms this dynamic. It works by intelligently moving emails, identified as candidates for archive based on policy, from that expensive high-performance primary storage where active emails reside, to the more economical and durable archive storage device. The whole process is driven by a defined policy.
Like archive everything older than 90 days.
Exactly. A common policy might be emails that are 90 days old should be automatically archived, or maybe emails older than 1 year that haven't been accessed in the last 6 months. It's flexible. Once archived, these emails are then retained for many years, often based on specific retention policies tied to legal or regulatory mandates. This ensures they're always there if needed for however long they need to be kept.
Okay, so the old stuff moves out automatically. What are the benefits?
The benefits are truly transformative across several fronts. Firstly, obvious one: considerable savings on primary storage. Organizations no longer need to allocate massive amounts of their most expensive high-performance storage for aging email data that's rarely, if ever, modified. This frees up budget and resources immediately.
Makes sense. Cheaper storage for older stuff.
Secondly, it ensures robust regulatory compliance. It guarantees the long-term preservation of critical communications, which is absolutely vital for legal discovery during lawsuits, for internal and external audits, and for adherence to various industry and government regulations, things like HIPAA for healthcare or SOX for financial reporting.
Takes the guesswork out of keeping records.
Exactly. And perhaps most impactful for the end user, it provides virtually unlimited mailbox space. Users no longer have to worry about frustrating quotas or that agonizing decision of deleting potentially valuable historical emails. Pretty much. They can access everything seamlessly, as if it were still in their primary inbox, simply by clicking on those stub files that transparently retrieve the archive content from the high-capacity archive. It's a huge win for productivity, for peace of mind, and it drastically reduces help desk calls about full mailboxes. It truly liberates the inbox.
That's a clear win for email. Definitely see the value there. Now, another incredibly chaotic environment that benefits greatly from archiving is the traditional file sharing setup. You know, those shared drives in many organizations that often become sprawling, unmanaged repositories, a veritable digital Wild West, as you put it earlier, difficult to navigate, even more difficult for IT to manage. I've certainly seen my share of shared drives that look like digital junk drawers.
Oh, you've certainly described the reality for many IT departments. It's a common struggle. In countless organizations, users store a truly vast number of files in shared network locations, departmental drives, project folders, maybe even personal network shares. The issue is, a significant portion of these files are actually quite old. They're rarely accessed after a certain period, maybe after a project ends, yet they continue to consume valuable primary storage capacity, terabytes of it sometimes.
Just sitting there taking up expensive space.
Exactly. So IT administrators, in a valiant attempt to manage this sprawl and control escalating costs, often resort to configuring quotas on these file shares, just as they would with email mailboxes, which, once again, forces users to make tough decisions about deleting potentially important files they might need years down the line. Or it leads to a constant stream of urgent requests for, can I have more space, increase my share size, which directly escalates primary storage costs. It's that constant battle again. User convenience versus essential data preservation versus strict IT budgets.
So how does an archiving solution effectively tackle this digital hoarding and the associated cost problem in file sharing environments? Does it offer the same kind of liberation we saw with email?
Absolutely. A file archiving solution mirrors the successful approach we just discussed for email archiving. It brings the same level of intelligence and automation to those shared network drives. It intelligently archives files from the shared location to the dedicated archive storage based on predefined policies. Again, highly flexible policies. These policies can use criteria such as the age of the files, maybe archive all files not accessed in the last 180 days, or their size, move any file over 50 millibit that hasn't been touched in 90 days. Or even specific file types, archive all video files immediately after creation.
So it automatically cleans up the old unused files from the primary share.
Right, and this provides an immediate and considerable reduction in the primary storage requirement for these active file shares. That's a significant cost-saving measure for IT right away. Less money spent on expensive high-performance disk arrays for data that's just sitting there.
Okay, cost savings. What about user access?
Crucially, just like with email, it also enables users to retain seamless access to these files and the archive for much longer periods, often years or decades, without consuming that expensive primary storage. They access the archive files transparently via the very same stub files we discussed earlier. Click the file, it comes back.
So again, the user doesn't even know it's been archived.
Often, no. From the user's perspective, the file's still right where they left it in the shared drive structure. They're usually completely unaware that it has been moved from its original high-cost location to a more economical long-term archive. This not only optimizes storage costs by moving cold data to cheaper, more durable storage tiers, but it also greatly simplifies the lives of administrators by automating cleanup. And it ensures that valuable long-tail data information that might be accessed infrequently, but is still important for historical context or future reference, is always preserved and accessible when needed, without requiring human intervention to find it. It's a huge step towards taming that digital Wild West we talked about.
Wow. What an insightful deep dive into the world of data archiving. We've really covered a lot of ground. We journeyed from understanding what fixed content truly is, those immutable digital treasures that just accumulate over time. We explored the significant limitations and, frankly, surprising hidden costs of those old tape and optical disc methods.
Yeah, the operational overhead was staggering.
And then we dissected the elegant, intelligent architecture of modern archiving solutions with their vigilant agents, their policy-driven servers, and that specialized content address storage. The whole stub file thing is quite ingenious.
It really is a clever system.
Yeah.
And we've seen the tangible, real-world benefits this brings. From liberating our inboxes and taming the Wild West of shared drives by providing virtually unlimited space, to ensuring critical compliance with ever-evolving regulations and avoiding those potentially crippling penalties, and even unlocking entirely new business value from historical data, turning archives into assets.
Right. It's clear that data archiving isn't merely about cold storage or just deleting old files. It's really about making vital knowledge consistently available, provably authentic, and easily manageable over the long haul, the entire lifespan of an organization, really.
It's about transforming potential digital liabilities into strategic assets, making sure that history is usable.
Absolutely. So, as we wrap up this deep dive, here's a thought for you, our listeners, to mull over. In a world of ever-increasing information where data is created faster than we can possibly imagine, the true power and lasting value lie not just in creating that data, but in intelligently preserving and accessing the wisdom it holds, potentially for decades to come.
So the question becomes, what fixed content might you have in your own digital life, or maybe within your organization? What's waiting there, ready to reveal its long-term value, if only it were properly archived and made accessible? Something to think about.